how do you know this graph is rational? Let's start easy. My intermediate algebra class is talking about rational expressions right now, so I can't remember which of you I've been torturing. What is a rational number? It's a number that you can turn into a fraction. So what do you think a rational function would be? It's going to be an equation that has what? And specifically, what's in the denominator of our fraction? A variable, because that gives us undefined values for our domain. So let's talk about the difference between polynomials and rationals. Why do we like polynomials? Because you said so. Why do we like polynomials? Because why? Easier. Why are they easier? Because, yeah, sometimes you can factor them. Why are polynomials easier than rational expressions? What do polynomials look like? They're continuous, okay? So we like polynomials. If you want to draw a continuous graph, do you have to lift your pencil up to draw it? No, you shouldn't have to lift your pencil up to draw the graph. The reason why we don't like rational functions as much is because look at example 3. That is a graph of a rational function. What do you notice about it? There's different pieces of our graph. You can see right here, that's part of our graph. You can see in the middle, we have another piece of our graph. You can see on the right-hand side, we have another piece of our graph, and they're split up. So rational functions are a little more difficult because they have domain restrictions. When you have rational functions, they're going to have domain restrictions, which means it's either going to be a vertical asymptote or you could have a hole. So that's why we like polynomial functions, because we don't have to find any values that x is not allowed to be. All right, let's look at example 3. Part A, find the domain and range. The domain for this function, we are measuring the x values. So for the domain, how far to the left does our graph go? Negative infinity. And then it looks like we have kind of a pit stop where? -2. And not specifically just -2, but it looks like it's getting really close to what? If that arrow keeps going, where is it going to keep getting closer and closer to? Let's locate the vertical asymptote. So I'm going to skip down to D. So there's A. I'll leave room for B. We'll leave room for C. And we're going to skip right down to D. It's asking us to figure out where the vertical asymptotes are. Those are going to be our vertical dashed lines, and our graph is not allowed to cross them. Where is one vertical asymptote located? We have one at 3. So right here, I'm going to go in, put in my dashed line. So this is at x equals 3. It looks like there's another one. Where is that one at? -1. Those represent our vertical asymptotes, x equals -1. So when we identify our vertical asymptotes, we have one at x equals -1 and x is equal to 3. Let's go look at part C. Do you see a horizontal asymptote? It's the dashed line that's going across horizontally. It is located at y equals 3. Okay, go back to A. We factored them and the denominator did not cancel with the numerator. So your graph is allowed to be all the real numbers. It's just not allowed to be equal to the vertical asymptotes or the whole. Our domain, it's going to go -infinity, and we're reading from left to right. So where do you see we're going to have a problem on our domain, starting all the way from -infinity and then going to the right? Where's our first issue? -1. So our domain is going to be -infinity to -1. Should I use a parenthesis or a bracket around that? Parenthesis, and the reason why is because is your graph allowed to cross that vertical asymptote? No, so it's allowed to get really close to it. It's just not allowed to cross it. So it's meaning -infinity to -1, parentheses, union. Where does our graph pick back up? -1, going until we get to measure my domain. I am looking from left to right. I'm going from -infinity until we get to -1. I'm going from -1 until we get to 3. And then we're going to go from 3 until we go to positive infinity. I'm just breaking this up into pieces. So the last part of this is going to be union, and we're going to go 3 to infinity. That is our domain. It's also asking us to find the range. So range means we're going bottom to top. We want to go smallest number to our biggest number. I'm going to do a highlighter because I feel like that's helpful. So for this first piece, it looks like we are going until we get to about 3. The piece all the way to the right looks like it's going negative infinity until we get to 3. But look at the piece in the center. Does it go all the way through? So what's our range going to be? You don't need to include the 3 because it's going to cross in the center. It goes through the 3. So our range is going to be negative infinity to positive infinity, or you could have said all real numbers for y. Let's look at B. We're looking for the intercepts. Let's start with the x-intercepts. How many x-intercepts do we have? We have 2 of them. X-intercepts is where it crosses our x-axis. We have one at 0, 0, and we have another one when we go to the right 4. So this is going to be 4, 0. And let's go ahead and look at our y-intercept. You're only ever going to have one y-intercept. How come? Because it has to pass the vertical line test. So if you had 2 y-intercepts, let's say we had one up here, it wouldn't pass the vertical line test. So you're only ever going to have one y-intercept. As far as our y-intercept, we kind of already have it labeled because it's 0, 0. But I'm going to write it again because our 0, 0 represents the x-intercept and the y-intercept. And then E. Do we have any oblique asymptotes? Can you have horizontal asymptotes and oblique asymptotes? Not at the same time. You can't. You can either have horizontal or slant. That's all you got. You can't have both. Okay, so you either have horizontal asymptotes or slant asymptotes. So in this graph, we would say there are none. They're called slant asymptotes, or the other name for them is oblique. They're the same. Math with like 30 different names. Let me ask you a question. Maybe this will start to kick in some of the rules for our horizontal asymptote. I did not give you what the function looks like. Which scenario do you think happened there? What was our horizontal asymptote again? We got y equals 3. So does that match the first scenario? No, because our horizontal asymptote was y equals 3. So that is not going to work. Let's look at number 3. It says we have no horizontal asymptote. So does that match what we have? No. The degree of the numerator and the degree of the denominator were the same. So the coefficients were probably 3 over 1. That's how they got the 3. And we're going to do this. I'm just trying to see if you could put 2 and 2 together. All right. Let's look and talk about some of things that's going to happen on our graph. The way that we graph rational functions is we use all our information that we can get from the actual function itself. And we try to identify the domain. Do we have a hole there? Do we have vertical asymptotes there? We identify places that are going to give us some domain restrictions. Then find any other asymptotes. That means, are we going to have any horizontal asymptotes or a slant asymptote? Third thing we want to do is figure out if we have any intercepts. We're looking for x-intercepts, which is where you make your numerator equal to 0. And then we're going to find the y-intercept, which is where we plug in x equals 0. Last but not least, that is not enough information to graph a rational function. We're going to have to make a table of values and pick numbers for x to plug into our function, okay? That's the steps to graph these. For your holes, you can find the matching y value for the hole by plugging it into the simplified function. I'll put that in parentheses. That is an option that is helpful. Let's go ahead and look at example 4. We are going to simplify it as much as possible, and then we're going to look at that function and then compare it to the graph that I have on the right hand side above it. F of x. How do we know this is a rational function? There is a variable in the denominator. If we wanted to simplify this, what do you think we should do? Factor. We need to factor. So let's go ahead and factor the numerator. Okay, right now we have 2x squared minus 7x plus 6. First thing you want to ask yourself is, do I have a greatest common factor? We do not. Next question you want to ask yourself is, how many terms do I have? 3. If you have 3 terms, we have a trinomial, and we want to figure out what is my A value. Is A equal to 1? No. So the way that you would factor this is you can do the AC method, you can do the X method. I've seen people do the box method. I do bottoms up method. So I'm going to get my 2, I'm going to multiply it by the 6, and I'm going to go ahead and rewrite this. We will get x squared minus 7x, and then 6 times 2 is plus 12. From here, we need to find the factors of 12, and we need them to add up to our B term. So 1, 12, 2, and 6, 3, and 4. We need them to multiply to get us a positive 12 and add up to get us a negative 7. What 2 numbers do we want? 3 and 4. And we need them both to be negative. As soon as you find your 2 numbers, we're going to go to factored form. This would be x minus 3 times x minus 4. Last but not least, because I multiplied by 2 in the front, I have to undo that. So I need to get both of my numbers and put them over 2 over 2. If the bottom doesn't go into the top number evenly, it's going to come up front. So this will factor to be 2x minus 3. If it goes in evenly, we're just going to divide, and this will become x minus 2. We're going to go ahead and rewrite this. F of x is equal to 2x minus 3 times x minus 2, and this is all over x minus 2. From here, does anything cancel out? X minus 2 goes away, x minus 2 goes away. So for f of x, what is our domain restriction for this? Yeah, x is not allowed to be equal to 2. And because it cancels out with the top, would we have a vertical asymptote there, or we're going to have a hole there because it cancels? Okay, our simplified function is f of x is equal to 2x minus 3. If I asked you to graph that, 2x minus 3, what would it look like? It's going to be a line. We have y-intercept at negative 3, and our slope is 2. Let's go look at the graph that I have up here. If I go down to negative 3, put in my point, and I count up 2 to the right, up 2 and to the right. Why is there an open circle there? Okay, so the reason why there's an open circle there is because we have a hole. Our denominator canceled out with our numerator. From here, we know that at x equals 2, there is a hole. What is the y value? If you're trying to find the y value of the hole, all you're going to do is plug in that value to the simplified function. So we would be plugging in f of 2 is equal to 2, plugging in 2 for x, minus 3. When you simplify that, we'll get 4 minus 3, which is equal to 1. We will end up having a hole on the graph at 2, 1. So that should match our graph above. You go to the right 2 and up 1. That's where the hole is, and that's how you can find it algebraically. For each of the following functions, what type of functions are these? For A, we have x plus 4 on the bottom. B, we have x plus 3 on the bottom. C, x squared plus 5x plus 6 on the bottom. We're going to be graphing rational functions. We need to figure out what the holes are, if there's vertical asymptotes, if there's a horizontal oblique asymptotes, then we're going to come up with what the intercepts are. And then we might even need to plug in some more values and figure out what our graph is going to look like. Notice that the directions say sketch the graph. We're just trying to get the main gist of what's happening, okay? All right, let's start with A. You always want to factor first, if you can. For our function h of x, do we need to factor anything? We don't, and the reason why is because in the top we have an exponent of 1, bottom we have exponent of 1. There's nothing for us to simplify at all. We need to figure out what our domain restrictions would be. So I'm going to kind of do A and B at the same time and write over here that these are the domain restrictions. This is where our denominator is equal to 0. We would say x plus 4 is not allowed to be equal to 0. When you go to solve for x, we're going to get x is not allowed to equal -4. So that's our restricted value. Is that going to be considered a whole, or is that going to be considered a vertical asymptote? It's going to be a vertical asymptote because it didn't cancel with anything in the numerator. We would say there are none because denominator doesn't cancel. So for part B, vertical asymptotes are when your denominator equals 0 and it doesn't cancel. So we have a vertical asymptote where x plus 4 equals 0. We already solved for it. Our vertical asymptote is going to be located at x equals -4. I'm going to sketch in a vertical asymptote at -4, something like that. Okay, now we want to go ahead and look at part C. When we're looking for horizontal asymptotes, we want to look at the degree of the numerator and the degree of the denominator. What is the degree of the numerator? We have a little exponent on our x, which is 1, and the degree of the denominator is equal to also 1. When they are equal to each other, then that means that we make a ratio of their coefficients because these are the same. Y is equal to, the coefficient in front of the x on the top is a 2. The coefficient in front of the x on the bottom is a 1. So our horizontal asymptote is just at y equals 2. So I'm going to go to my graph, put in our horizontal asymptote at y equals 2. For D, are we going to have a slant asymptote? No. There are none because we have horizontal asymptote. Let's now move on to this next part, determine the intercepts. I don't know why I didn't give it a letter. E. I'm making up a letter. Let's go ahead and find what our x-intercepts are first. When you want to find your x-intercepts, what are we going to do? We always set y equal to 0. We only want to solve for the top. What happens when we set the bottom equal to 0? It's undefined, right? We already found our undefined values for x. So that's when you make the bottom equal to 0. We're still plugging in y equals 0, but we specifically want to solve for the numerator. 0 equals 2x minus 3. And from here, we want to go ahead and solve for x. I would need to add 3 to both sides. We get 3 equals 2x, and then divide both sides by 2. And we end up getting x equals 3 over 2. If I wanted to write this as a coordinate, I would say 3 over 2 comma 0. Let's go ahead and find our y-intercept. I'll do it in a different color. How do you find a y-intercept? We make x equal to 0 and solve for y. Y is equal to 2 times 0 minus 3 all over 0 plus 4. When you simplify this, we end up getting -3 over 4. You can write it as a decimal. It's a little bit easier to plot your coordinates there. So we're going to go 0 down -0.75. Looks something like that. Just by analyzing this function right now, that's all of the pieces of the puzzle that we have. Now what we want to do is sketch the graph, and we're going to do that by plugging in values. We have x, and our function is h of x. We're going to pick some numbers and plug them in so that we can figure out what our graph is doing. It looks like these are going to be connected. We know our graph is going to get really, really, really close to the vertical asymptote. It's just not actually going to cross. Problem is, we don't know what's going on over here. We have no information. So that's why we need to plug in values and figure out what's happening. One number that I would probably plug in is going to be -3. Do you see how it's getting closer to the vertical asymptote there? That's why I'm picking -3. You're just going to plug it into the function and evaluate it. H of -3 is equal to -6 minus 3. This becomes -9. So we just found another coordinate at -3, -9 by just picking a number and plugging it in, okay? So same kind of idea. Remember I said it's going to get really close to the vertical asymptote. we need to figure out what's going on with the values on the left-hand side of our vertical asymptote. So what do you think a good number would be to plug in? Probably -5, because we don't know what's going on that side. H of -5 is equal 2 times -5 minus 3. This is going to be all over -5 plus 4. So -13 all over -1. Negative turns positive. So this is actually going to be 13. We found another coordinate on the graph at -5 and 13. Our graph is going up towards the vertical asymptote because it's way up there. Let's pick another number. When you plug in -6, we'll get h of -6 is equal to -15. This is going to be all over -2. This is also going to turn positive. You can continue to pick numbers and plug them in. So our graph is going to look something like this. And eventually it'll get to the horizontal asymptote. So the reason why I picked numbers that I did is because we were trying to figure out what was going on to the left-hand side. Is our graph up there or is our graph down there? That's why we were plugging in numbers. It's the leading coefficient. So it's this 2 and this 1, and that's where you get that 2/1 from. Anybody else? All right, so the next one. First thing I'm going to do, because it's annoying me, is I'm going to rewrite my function because I want to put them in order from biggest exponent all the way down to the smallest exponent. I'm going to go ahead and rewrite this, and I'm going to put the -x² in the front plus 5, and this is going to be all over x plus 3. From here, let's go ahead and talk about what our domain restrictions are going to be for this example before we answer A through B. Domain restrictions. Do we care about the top or the bottom? You care about the bottom. We're going to get x plus 3, set that equal to 0, and solve for x. So x is not allowed to be equal to what? X is not allowed to be equal to -3 because when you plug it in, what happens to your function? Turns it to 0, which is undefined. Okay, part A. Do we have any holes for this graph? No, I'm going to do my best to follow the same colors. Apparently I didn't pick a color for that. So there are no holes on this graph, and the reason why is because it does not cancel. Let's look at part B. We need to figure out if there's any vertical asymptotes for this graph. Do we have any vertical asymptotes? Yes, it's at x equals -3. I'm going to go to my graph and sketch that. Part C. Horizontal asymptote. Okay, the degree of the numerator is what? Is 2. The degree of the denominator is what? It's 1. So the degree of the numerator is greater than the degree of the denominator. Do we have a horizontal asymptote? The easiest way to think about this is we all know what an improper fraction is, right? The bigger numbers on the top, smaller numbers on the bottom. If it's an improper fraction by degree, then you don't have a horizontal asymptote. You can kind of think about it like that. Okay, in order to figure out if you have a slant asymptote is by looking at your degree. If the degree of the denominator is 1 less than the degree of your numerator, then it's going to have a slant asymptote. So what do you think for this? Yes, the way that we find out the equation for our slant asymptote is by either using long division or by synthetic division, whichever one you prefer. Do you want to do long division or do you want to do synthetic division? Okay, synthetic wins. Our denominator, it's x plus 3. That means we're going to be divided by -3. We're going to need to put the coefficients in the top row. Our numerator, -x² plus 5. Are we missing any terms? Yes, we're missing the x that's all by itself. So in the top line, we're going to put -1. I need to put in a 0 because we're missing our x, and then a 5. When we're doing synthetic division, bring down our first number, which is -1. We get that number and multiply it to the outside number. -1 times -3, add our column together, we get 3. Just keep repeating. 3 times -3, -9. Add those together, -4. We really don't care what the remainder is because we need this linear equation to graph our slant asymptote. We started with an x squared when we were dividing this out. It's going to be 1 less. So that means that this would be the coefficient in front of x, and then this is going to be our constant. When we go to write this out for our slant asymptote, we're going to have y is equal to -1. That's your coefficient. And then we're going to have an x. And the reason that represents our x is because we started with an x squared. When you divide things out, it gets smaller by 1. So this is going to be -1x. And then plus our constant, which is 3. We don't care about the remainder because we just need to be able to graph y equals -x plus 3. Okay? Do we know how to graph y equals -x plus 3? What is it? It's a linear graph. Our y-intercept is at 3. Count up 1, 2, 3, put in a little point, and our slope is what? -1, so we're going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. I'm just putting in little points because I'm going to connect those with dashed lines because that's going to represent our slant asymptote, and it's going to look something like this. Okay, our slant asymptote, also known as oblique, y equals -x plus 3. Our graph needs to be within those asymptotes, between the vertical and your slant. All right, next, how do we find the x-intercepts? We want to set the numerator equal to 0. We need to solve for x. First thing we need to do is what? To the other side, so we subtract 5, we get -5 is equal to -x squared. Now what? Yeah, we gotta divide or multiply everything by a -1 because there's a negative in the front. So this would be 5 is equal to x squared. Now we can go ahead and take the square root of this. We are gonna get x is equal to, what do I need to put in front of my square root? Perfect, plus or minus. I'm like a broken record. Square root of 5. And we don't know how to graph the square root of 5, so we're going to figure out what that value is approximately equal to. Second square root 5, and we're going to end up getting approximately plus or minus 2.2. Let's go to our graph and put in our x-intercepts. I'm going to go to the right, 2.2. I'm going to go to the left, -2.2. Those are our x-intercepts that we found. Now we want to go ahead and figure out what our y-intercept is. How do we find a y-intercept? We're going to plug in 0 for x. So y is equal to 5 minus 0 squared all over 0 plus 3, 5 over 3. Rational functions are not very nice to us because you see how we get these terrible, ugly fractions a lot of the time. That's why they're not as fun. In a calculator, it's going to be approximately 1.67. So in coordinate form, it's 0, 1.67. I can go ahead and put that on the graph. It's going to be somewhere around there. Okay, this is what our graph kind of looks like. If you didn't want to plug in any values, we know that the graph is going to be getting really close to our slant asymptote and our vertical asymptote. So it's going to look something along the lines of this. The other thing is we don't know what's going on with the graph on this side. So we would need to plug in some values. What is a good number you think we should plug in? Yeah, anything that's going to be on the left-hand side of that vertical asymptote is really going to be helpful for us. Let's make x and call this f of x. And all we're doing is just picking a number and plugging it in. Let's go with -4. This is going to be equal to -4 squared plus 5 all over -4 plus 3. -4 squared is going to get us 16, but the negative's on the outside again. So we get -16 plus 5, and this is going to be all over -4 plus 3, which is -1. When you simplify, -16 plus 5, which is -11, all over -1. 2 negatives, we get positive. So our y value that matches -4 is going to be 11. Now, if you look at the graph, we don't have enough space on our graph to put in the coordinates for -4, 11, but it's going to look something along the lines of that. It should almost mirror what we have on the bottom, okay? Questions on what we did so far? Alrighty. So if you were to plug in any numbers for 5 and 6 to see if you have something up there, you're not going to have anything up there, because if you did, well, it's not going to pass the vertical line test. Let's do the next one. This one is a little bit different. What do you think you should do first? Factors, see if anything cancels,